We've solved systems of equations by graphing, by substitution method, and by the elimination method. And now we're going to organize our systems into what we call matrices. So in order to do that, we need to know a little bit about a matrix and some vocabulary. The order is the size or the dimension of a matrix. And the order of this given matrix right here happens to be a 2 by 4. So it's the dimensions of this matrix. So we always name our matrices or given order by the rows first. Wow, that is super thick marker, huh? Right, rows by columns. So the rows come first and then the columns follow. And we'll do rows by, we mark by with an X, columns. So in this case we have 2 rows and we have 4 columns. So the rows are horizontal and the columns are vertical. The words order, size, dimensions, these are all synonymous. They all mean synonymous. They all mean the same thing. Okay, so let's practice. What's the order of each matrix? The order of each matrix. Here I have a matrix with 1 element. So these are elements. Let's go back up here and write that. Each one of these are elements. So in matrix A, we have 1 element. That means we have 1 row, 1 column. Row 1, column 1. That would be a 1 by 1 order. Okay, the next one, 1, -3, 0, 1/2. This right here is 1 row. Rows are horizontal, so row 1, but then we have 4 columns. Column 1, column 2, column 3, column 4. So it's rows by columns. Rows by columns. So 1 row by 4 columns. That's what the size, the dimensions, or the order would be. Okay, you go ahead and try C and D. And if you are back, I'm going to give you the answer. C is a 2 by 2. And D is a 3 by 2. So I think that we're ready to move on. An augmented matrix is an array of numbers that is shorthand for a system of equations. So an augmented matrix is shorthand. It's just another way of saying a system of equations. We're going to have our coefficient matrix to the left. Then we're going to have a bar that stands for the equal sign. And then on the right hand side of the bar, we're going to have our constants. And that's an augmented matrix. So if our system of equations is 2x plus 5y equals 10, and 3x plus 4y equals 24. our x's line up. They're going to be in the first column. Our y's line up. They will be in the second column. Our equal to signs line up. That's the bar. And then our constants are on the right-hand side of that bar. So we'll have 2 and 3. Those are our coefficients of our x variable. Then we'll have 5 and 4. Those are coefficients of the y variable. And then we'll have 10 and 24. Those are the constants. And that's an augmented matrix. We're going to write the augmented matrix for this system. Now this system has 3 variables in it. So we're going to have a column for x's, a column for y's, a column for z's, and then we'll have the bar for the equal sign, and then we'll have our constants. So our x's, our y's, and our z's. I'm also going to say this is equation 1, equation 1, equation 2, and equation 3. Actually, there's a 4th one there. I'm going to make these a little, because I don't want to squeeze that in, so I'm just going to make this a little bit longer. There's a 4th one there, equation 4. So for equation 1, we're going to have 1, negative 1, negative 1, 10. So positive 1x, negative 1y, negative 1z, 10. Equation 2, we're going to have 2x plus 1y plus 2z equals negative 1. Equation 3, negative 3x plus 4y equals 0, or plus 0z equals 5. So there's no z, so we put a 0 in that place. And then 4x minus 5y plus 1z equals 0. And there's our augmented matrix. Now what we're going to be able to do with these augmented matrices is we're going to be able to solve using Gauss-Jordan elimination. You replace equations with scalar multiples, you add equations, you subtract equations, and we can swap equations. We want to get reduced row echelon form, and that means that we need to get a coefficient of 1 in row 1, column 1, and zeros in all the entries below it. We need a coefficient of 1 in the next row in a column other than C1 with zeros below it, etc., etc. So in essence, what we're going to want is we're going to want diagonals of, that'll be some number. Let me make this a 3 variable right here, 0, 0, 1. So what we're going to want is we're going to want 1s in our diagonals, because this is going to be x, this is going to be y, this is z, and then you have a constant. So this would tell us 1x equals a number. This second one would tell us 1y equals a number. And the last one would be 1z equals a number. So that's why we want to get 1s in the diagonals and zeros everywhere else. So the next video, we're going to solve this system of equations using Gauss-Jordan elimination.